This lesson, as you can see, is we're going to find the areas of irregular shapes. I look at it a lot of, it's a problem-solving lesson, and we want to find the area of these irregular shapes. So in this case, I just want the area of the orange region. So what I want to do for the starters is look at my big picture. What do I have involved here? Well, I look at it and there's this big rectangle. Just highlight it real quick so that we all know what I'm talking about. There's the big rectangle, and then there's also the little rectangle right in here. So think about this. If I just want the orange part, I'm going to find the area of the big rectangle that I have highlighted in yellow. I'm going to find the area of the green rectangle, and then I can subtract them because I'm cutting out the green rectangle that I've highlighted, or what used to be white. So I look at this, and I'm going to start with the area of my orange rectangle, or the big rectangle, I should say. So I'm going to use black for that, area of the big rectangle. And I'm going to have to do base times height. Well, I see that the base of this is 100. The height is 50. So the area of the big rectangle is going to be 5,000 centimeters squared. Now I need to find the area of the smaller one. Well, this is going to require a little bit of work before, because I don't know the length of the base and I don't know the length of the height. I do look here and I know that this distance is 40, I know this distance is 25, and the whole thing on the bottom here is 100. So if I take the 100 and I subtract out the 25 and I subtract out the 40, I'm going to end up with 35 centimeters for the length of that base on the bottom. Then I'm going to have to do something similar to find the height here. Well, I notice that this distance here is 20, this one's 10, the whole side of the big rectangle is 50, so to find this piece, if I take 50 and I subtract out the 20 and I subtract out the 10, I'm going to be left with 20 centimeters for the height. Well, now I can find the area of my little rectangle. So area of the little one is going to be 35 base times height of 20, and that's going to equal 700 square centimeters. So then to find the area of just the orange part, I need to subtract those values, as I said earlier, and I find out that 5,000 minus 700 is going to put me at 4,300 centimeters squared. Now this next figure is a little bit more in depth. And what I'm going to try to do is try to take pieces and maybe put them together. And the reason I say that is because I'm looking at this piece over here and I notice that I have a triangle and I see that two of the sides are congruent, but then I come over here, I see this and this congruent, but then I can kind of go like this, and I see a big rectangle there, which is going to tell me that this piece here is going to be congruent to the white dashed one over here. So now I have side, side, side of the triangle over here on the left that's kind of the cutout, and I have side, side, side of over here with this green triangle. Well, then what I can do is I can take this triangle and essentially just stick it right there. So what happens then is now I have that one big rectangle on top, and then I have my trapezoid on the bottom. So all I have to do now is to find the area of this would be to find the area of the rectangle on top, find the area of the trapezoid on the bottom, and add them together. So what I'm going to do is I look at my rectangle on top. I know the length of the base. I know the length of the height. I can find my area. So area of the rectangle, base is 35 inches, height is 20 inches. Multiply those two things together, and I end up with 700 square inches. Now I got to go to the trapezoid. Now on the trapezoid, I know I need the length of the two bases, and I look and I know that I have the bottom base is 30 inches, but that top base, which would be right here, that one I don't have yet. So I'm going to come back up here and go that I know this is 35, this part's 5, this part's 5, so then what I need to do is I need to do 35, subtract out those two 5s, and I'm going to find out that that top base is going to be equal to 25 inches long. I also need to be able to find the height. Well, I notice the height of the entire figure with the rectangle and the trapezoid together is 30 inches, but this part here is the 20, so if I take the 30 and subtract out the 20, I just found out that the height of my trapezoid is 10 inches. And now I have everything I need to calculate the area of my trapezoid. So come down here, and all I'm going to do now, the area of the trapezoid is going to be 1/2, well, base 1, I'm going to call it 30. Add on my other base, which would be the top base, that's going to be 25. And then I have to multiply that by the height of my trapezoid, which I just found out to be 10. Do all my calculations on this. I'm going to do them kind of in my head here. So I'm going to look at the 30 plus 25. Well, that's 55. And then I'm also going to do the 1/2 times 10. 2 is going to become 1, the 10 is going to become 5. So now I have 55 times 5, and 55 times 5 comes out to be 275 square inches. And then to find the area of the whole thing, just add my rectangle and add my trapezoid together, and I end up with 975 square inches for the area of that irregular shape. And now my last one, I have a pentagon, it tells me, pentagon A, B, C, D, E, and it's on the coordinate grid. So the first thing I'm going to want to do is I'm just going to want to graph my points. -5, 0, there's my A. I have -3, 7, there's B, 110 is C, 3, 7, there's D, and then E is at 3, 0. So I need to find the area of that pentagon. And to do this, I'm going to break it up into pieces that I can find the area of, because I don't know how to, there's no formula to find the area of a pentagon unless it's regular, and clearly that is not a regular pentagon. So the first thing I'm going to do is I'm going to essentially cut off the top, and then I have a triangle. I know how to find the area of a triangle, so that shouldn't be a problem. And then I look at the bottom piece, so I know that this part and the bottom of my pentagon are horizontal, so they're parallel, and then my left side and my right side are not parallel, so I have a trapezoid. So what I'm going to do is I'm going to find the area of the triangle on top and the area of the trapezoid on the bottom. So if I start with my triangle, I need to find the length of that red piece. Well, one way to do it would be to count, so I could count my squares. I have 1, 2, 3, 4, 5, 6. So I know the length of that is 6. Now another way to do is if I look at point B and D, and all I really need to focus on are the x values, because notice the y values are both 7. Well, how far is it from -3 to +3? Subtract them. -3 minus 3, it's -6. Distance is always positive, so my length is 6. But then I also need to know what's the height of my triangle, which would be right here. Well, one, I could count it. If I count it, I find out that that length is 3. Or I can go to C. Let me get rid of this now so it doesn't confuse me. The height at C is 10, and then really I went vertically down, so the height right here is going to be the height at B or D. So if I look at B, that's at 7. 10 minus 7 is 3. There's my height again. So I can find now the area of my triangle. Now my trapezoid, on the other hand, I have to find a little bit more information. I've already found the top base. I need to find my bottom base. And again, I could go to counting, or, forgot to put my E in here, I can go back to using the coordinates to find this. I know the heights at both of those, or the y value at A and E are the same. I can look at that, they're both 0. So then it's just a matter of, well, how far is it between the x values? So how far is it between 3 and -5? Well, if I take 3, subtract -5, I get 8. So now I have the length of two bases. All I need is the heights, or the height of the trapezoid. And I'm going to look at my height right here. And then I'm going to go back to E and to D. And the reason I picked E and D is because I know they both have the same x value. And then all I have to look at would be the y values at point D and point E. Well, how far is it between 7 and 0? You can subtract them and find out that it's 7. I have everything. Now it's just a matter of plugging it into the formula. So if I start out with my triangle, area of my triangle, 1/2 times my base, which is 6, times my height, which is 3, and I find out that the area of my triangle is 9 square units. Then it's the area of the trapezoid. Suppose T wasn't good. So TRA for trapezoid and TRI for triangle. Trapezoid is going to be 1/2 times my bases. Well, one of my bases is 8 plus the other base is 6, and then multiply that by the height, which is 7. And I find out that the area of my trapezoid, if I do 8 plus 6, add that together, I get 14. And then I'm going to take 14 times 1/2 and get 7. And 7 times 7 is 49. So the area of my whole pentagon will be adding these two numbers together, and it will put me at 58 square units. So like I said, this lesson, yes, is about irregular shapes, but I look at it as more of a problem solving, and you know, I can cut my figures into different shapes like this one and add them together. I did the same thing in this one, but on this one I had to take something out, which means I'd have to subtract. You just have to be able to look at that problem and figure out, do I need to add things together, maybe I need to subtract things. And in some problems you may need to add things together and subtract because different figures are added together, and then there's also stuff that's been cut out of it. So that will conclude my lesson on irregular shapes.